Good afternoon to everyone. And then continuation of our uncertainty. So now we are going to see about there is another one algorithm. It's called that is a hidden Markov algorithm. So already in previous class we discussed about Markov algorithm. So what do you mean with that Markov algorithm? So you may able to say that is formula behind that is that Markov.
So basically Markov's model states that there exist two random variables, such as A and B. Probability of A disjunction B equal to probability of A plus probability of B minus P of A conjunction B.
Okay, so very good. Give you a good class. So we know, so what is that Markov? So we are working with the two independent variables. So two independent random variables. So P of A, disjunction of B equal to, so P of A plus P of B minus P of A intersection B. So this is that Markov. But here we are going to be add up that is that another one parameter it's called that is the hidden Markov. So when in case we are going for the prediction, so some parameters may be in hidden side. We can't able to predict that. So in that moment, how we have to predict these hidden parameters? So what are all the issues may happen in that these things? That has been described by this man. It's called that is the Markov. Okay, so that term is called that is the hidden Markov. So now we have to be see what are all the things today we are going to see. That is the what is the Markov model, and then hidden Markov model, and then so three issues that is happening in the hidden Markov model. That is model evaluation, and then most probable path decoding, and last one that is the model training. So these three parameters we are going to see today. And now we have to be see. So what do you mean by that hidden Markov model? So previous class we studied about everything under the category of the probability. So these probabilities having that broad component is called that is the statistical methods. Okay. So the term is saying the HSM is a statistical model. The system being modeled in assumed to be a Markov process. So already we know what is that is the Markov process that is working as an independent variable. So now we have to be seeing, so how this hidden Markov model has been worked. So it's having that set of the states or that certain transitions or certain emissions. Now we are having that is the three varieties of the four varieties of the climatical conditions. Anyone can able to say, so what are all that four varieties of that climatical conditions?
Sir, the four seasons might be sunny, rainy, fog, snow.
Okay, so we know, so depends upon that scenario, So depends upon that scenario we know. We are having that is the season of rain, and we are having the season of that sunny, and then we have season of that fog, and then western countries we are having that season of the snow. So these things is happening. But the situation on prediction on what climate will happen on next day. So we can't able to predict that. So the weather people saying tomorrow may be that sunny, but actually the thing may be that fog, or that may be the situation of that rainy, or there may be the chances to be as a sunny. So why that model is called that is that hidden? I'm having that is one straight parameters. That means I'm having that is that rainy, I'm having that is that sunny, I'm having that is that fog, I'm having that is the snow. So these four parameters is called that is that fixed, and that's a straight parameters. But one thing it seems to be that hidden, which parameter is hidden, that will happen on that prediction. In case I'm asking, so what will happen on next Friday, or what will happen on the next Monday, or that what will happen on what Wednesday. So I have to predict from the previous values. So I'm having that is the certain previous values. But suddenly one low depression or that some climatical changes will happen at that sea, immediately the scenario, so what is specified that has been changed. So that situation is called that is the hidden situation. That hidden situation defined by this Markov model. That Markov model is defining along with the hidden parameters is called that is the hidden Markov model. Are people able to understand so what I said? Is it clear? Okay, so now we have to be see on these things. So in the past observation, I can able to say there may be the chances of the sunny, there may be the chances of cloudy, there may be the chances of the rainy, there may be the chances of the snow. But in our geolocation wise, we are not having that snow. Then we have to take it out these three parameters. Okay, so I'm specifying. I'm having that is I have to predict for the n days. So here for the n days, I am taking that is the parameter Qn, it's having that subset, I am having that is the varieties of the climatical conditions. So in that subset, I am specifying either this is sunny or rainy or foggy. We are having that is the several climatical parameters, but in that subset, so I took that is the sunny, rainy, and then so foggy. So from that Q, I have to specify what will happen on that nth day. Okay, so I have to say. So the formula is saying we want to find what will happen on Qn. So now I am coming to the base theorem. Already we discussed in the previous class. So let me have to predict with the previous data. So P of Qn given by Qn minus 1, n minus 2 and n minus 3. So these n minus 1, n minus 2, n minus 3 and then up to that n minus up to the Q1. So that is the n minus n minus 1 solrapo that will reach to the Q1. So I have to be specified all these parameters and then I have to apply that Bayesian theorem and then I have to predict so what will happen on that nth day. Okay, and the next slide now we have to be see about. So we are taking that is an example. Last 3 days I am having that is these climatical conditions. On day 1 I am having that sunny, day 2 I am having that sunny, on day 3 I am having that is that rainy. So from that probability I have to be finding out. So P of Q4 I am having this cloudy, and then so Q3 is that rainy, and then so Q2 is that sunny, and then so Q1 is that sunny. So from this parameter I am deriving this probability condition. And now, so we have to be already we stated about so these things in that weather. So only that depends upon on the today condition. இன்னைக்கு இருக்கக்கூடியதான condition என்ன அப்படிங்கறத மீன் பண்ணி தான் like we have to decide that. So this method is called that is the first order so Markov model. So already we stated that is the P of A disjunction of the B equal to P of A plus P of B minus P of A conjunction B சொல்றோம் இல்லையா. So it's called that is the first order Markov model. Okay, so now we have to be see so how the things is getting to be. So I'm deriving that is that one probability. So for that foggy, what is that probability? What is the sunny? What is that probability? And then so what is that rainy? What is that probability? So in case if the transition happen, so that is very important. So here we are having that is that one tomorrow's weather condition. So sunny, what are all the probability to be as a weather condition? One thing we have to say, in that weather we are saying that is the prediction and the data is talking about only that probability. So in the according to this situation on tomorrow, by sunny, that is the 0.8 probability, there may be the sunny. That means 80% we may expect that is the sunny, and then 0.05%. In case I am saying that is the 0.05 means 5% there may be the chances of the rain, and then another 15% there may be the chances of cloudy. So this way we can able to predict that, but on all combination should come to the value of that one. So that is important. So this is 80% and this is that 5% and this is the 15%. On whole we reach that value of that 100% that is equal to the one in that probability condition. So this way we have to predict. In case if there is the probability for that rain, so we have to be classifying at for the 0.2 there may be the chances for that sunny, and then so 0.6 for that cloudy, and then so 0.2 for that is 0.6 for that rainy, and then so 0.2 for that cloudy. Okay, so this way we have to be predict for that particular day. So per day there may be the chances of that sunny, per day there may be the chances of that rainy for that 0.2%, per day there may be the chances of the cloudy for that another 0.2%. So this event is called that is the transition happening on that event. That means transition in between sunny and foggy, and then so foggy to rainy, so rainy to sunny. Okay, so now we have to see about next slide. Next one. Okay, so previous. So now we have to be see about. So I am computing this probability thing. So this assumption. So previously we talked about that 0.2, 0.8 and 0.05. So all this parameter is called that is the Markov assumption. So we are making that is that assumption. Especially in that weather condition, if you are making that prediction, that will leads to that assumption alone. Okay. So from that assumption, we have to be come to the conclusion. Now we have to be talk about so what will happen on that is the hidden Markov. So all these things it's happening on that open side. So in outside I can able to see. So I can able to feel. So today is that sunny, or today is cloudy, or today is that rainy. I can able to feel, and then I can able to say, okay, on the next 1 hour there may be the rainy, or the next 1 hour there may be the sunny, or there's the next 1 or 2 hours there may be the cloudy. So I can physically able to identify. But the thing is that I have to be put it into the dark room for the 3 or 4 days. I don't know. So what will happen on that outside? I don't know. So when is the sunrise? So when is the sunset? So in that moment, how could I able to predict? So what will happen on that tomorrow? Okay, so this phenomena is called, that is the hidden Markov. And that's the next slide. So next slide. So we have to be see. So I have to be locked in the room for that several days, and then I have to be predict. So what will happen for that weather? So how could I able to identify? So in that moment, I have to be rely on that next person that has to be visited to my room. So I can't able to make an outside visit. I can't move out from the room. So that the person who are giving that is food to me, I have to be taken sample from him. What is his attitude and what are all the parameters he is taking when he has to come to feed the food to me. Okay, the point is clear. So நான் வந்து எங்க இருக்கிற ஒரு டார்க் ரூம்லயே வந்து என்ன ஹிடன் பண்ணி வச்சிருக்காங்க. அப்ப அந்த ரூம்ல இருக்கிறப்போ நான் வந்து I have to be predict that is the climate on tomorrow. So அப்ப அத நான் predict பண்ணனும் அப்படினா that's not possible. I am not having that any interaction with that natural thing. அப்ப அந்த மொமெண்ட்ல நான் எனக்கு டேட்டா செட் எனக்கு வேணும் அப்படினா எனக்கு யாராவது ஒருத்தங்க மீட் பண்ண வருவாங்க. எனக்கு வந்து ஃபுட் சர்வ் பண்ண வருவாங்க. So அப்ப அவங்களுடைய பாராமீட்டர்ஸ் என்ன அப்படிங்கிறது let I have to be find out. இப்ப say example, so வரக்கூடியதான person வந்து ஓவர் செட்டிங்கா வரான்னு வெச்சுக்கோங்களேன், and then I can able to come to that conclusion in outside there is more sunny. So the point is clear. புரிஞ்சிருச்சா? இப்ப same meanwhile, so உள்ளுக்கு வரக்கூடியதான person வந்து ஒரு umbrella பிடிச்சிட்டு வரான்னு வெச்சுக்கோங்க, and then I can able to come to the conclusion somehow rain is there. So வெளியில மழை பெஞ்சிருக்குது, அதனால தான் அவர் எதை பிடிச்சிட்டு வந்திருக்காரு, கொடையை பிடிச்சிட்டு வந்திருக்காருன்னு அர்த்தம். அவர் வந்து ஒரு நல்ல ஒரு ஓவர் கோட் போட்டு வந்திருக்காரு, ஆனா கையில வந்து umbrella இல்ல, ஸ்வெட்டிங் இல்ல அப்படினா I can able to come to the conclusion வெளியில வந்து கொஞ்சம் fog இருக்கலாம், இல்ல அப்படினா ஸ்னோவியா இருக்கலாம். So ஒரு chillness வெளியில இருக்கிறதுனால தான் அந்த person வந்து என்ன பண்ணிட்டு வந்திருக்காரு, ஒரு ஓவர் கோட் வந்து போட்டு வந்திருக்காரு. So from that I can able to that conclusion. I am not making that interaction with the outside world, but outside la irundhu one person is coming to my room, from that person I am understanding what will the climate is happening on that outside. Now the point is clear. So this is that example for the hidden Markov model. Okay, so the point is clear. Okay, so up to this I am concluding this hidden Markov.